All right, so what I'm going to do is first talk a little bit, not too much, about the certification itself, and then we will go over some of the topics that was mentioned on the webinar site. Okay, so my name is Mehmet, and I do a lot of the ISACA and ISC Square classes, but I also do some CompTIA classes for training camp. I have over 30 certification. So what you might call I'm a professional test taker. So, but I really do like ISACA. They do very good. They have very good resources for the students, and I like the fact that they are more business oriented, including their COVID. So it's more about business oriented. So so the material we're going to be talking about is going to be more about CISA exam, you know, and we're not going to go in really in full detail, but there's going to be a lot of stuff that are more um, about auditing and stuff like that, but more about also how an organization should be, because as an auditor, your job is to look if they are doing the right things. Okay. All right, so it's this certification. So this is, it's a sales pitch from ISACA, but it does give you competitive edge. I believe that. And it is highly respected, highly regarded certification. And, you know, and provides global recognition. It's a globally recognized organization. And, you know, it will add value to your organization also. Okay. CISA is accredited, and that's important. It is accredited by ANSI, American National Standard Institution, which is the ISO's US version. Okay. And there are more than 118,000 people who have this certification. Okay. So a lot of people have it. Okay. All right. So typically this test has 5 domains, and you don't have to pass every domain. So you just, and the passing score is 450. So domain 1 is about system auditing processes. Domain 2 is about governance. Domain 3 is about information system acquisition, development, and implementation, SDLC stuff. Domain 4 is about operation maintenance and business resilience. And domain 5 is on protection of information asset. This is more of an management certification. It is from the management point of view. But, as an auditor, what is your role? What would be the role of an auditor? To make sure the organization meets certain standards and to show where organization may improve. Is there always a room for improvement? Always. There is always room for improvement. How come? Because no organization is perfect. Okay. So this term, passing an audit, is a terrible term. We're not doing the audit so we can pass it. We're doing it to show us, to help us where we can improve. The gap analysis. Where are some of the places where we can get better? But everything in our cybersecurity starts with risk management. Everything. And and we need to look at this from that risk point of view. So, and whatever we are doing, network security, application security, and so on, it's all about what? Reducing the risk to our organization. It's all about Risk management. And whenever I hear the term management, this to me implies that it's a continuous process. It's a continuous process. Okay. But risk management, and so when we are managing our organizations, we're making decisions based on, we are going to make these decisions based on risk and based on management's risk appetite. What is risk appetite? The level of risk organization is willing to take. One concept that I like so much that ISC Square has done, which I really like, is they also talk about risk capacity. Risk capacity. Many organizations don't talk about risk capacity, but organizations should not have a risk appetite that is higher than their risk capacity. So risk appetite should never be beyond the risk capacity. And this is usually not talked about in other areas. This is one that that they talk about, which I like about them. Okay. So every organization decides on what level of risk is acceptable to them, because we can never completely get rid of risk. Well, let me take that back. There is a time we can get rid of risk completely. That's when we get rid of an asset completely. Okay. But otherwise, we can only reduce the risk. So once we do our risk analysis, we determine our level of risk, then we come up with a risk response. Actually, let me take it two steps back. First, we need to determine what we have in an organization. We have to do asset management. We need to figure out what we have, and then we assign this asset to somebody. That somebody, the owner, determines the value and the impact of this, and then they come up with a classification. And based on this classification and so on, we look at the risk associated with this asset. So risk only exists if we have assets. Then we determine the risk level. We do our risk analysis, risk calculations, and then we come up with a risk response. And then these are the 4 risk responses we have. One is avoidance. Avoidance means what? We are not going to be we're completely getting rid of this asset. We are choosing not to do anything about it, or we eliminate it. Like we say, we're not going to accept credit cards, or we're going to fire this person, or we're going to get rid of an application. The problem with risk avoidance is what? Well, you fire a risky employee, then what do you usually end up have to do? You have to hire someone else. Okay. So risk avoidance has a cost. It's cost of opportunity. But many times we do risk mitigation. Risk mitigation is what? Putting in controls to reduce the risk level. To reduce the risk level to what? To an acceptable level or below. Risk transference, actually better term for transference would be risk sharing. We use an insurance company or we use a partner to do what? Take on some of the risk on behalf of us. Can we eliminate completely all the risk by transferring risk to someone else? Not really. Okay, and then risk acceptance doesn't mean we are rejecting the risk or we're ignoring the risk. Risk acceptance means we look at the risk level and we are fine with the level it is, and we choose not to do anything because the risk level is pretty low. Okay, that's the risk acceptance. So these are the 4 risk responses. We can never reject the risk, so there's no such thing as rejection and risk. Okay. So we need to have some purpose for risk management program. And this purpose needs to be aligned with what? With the organization's mission. Everything we do in an organization needs to be aligned with the organization's goals, organization mission. Okay. So this is what I was talking about earlier. First thing we need to do is what? We must have an asset management system. We must know what we have. If we don't know what we have, there's no way we can protect it. We do a threat assessment. We do an impact evaluation, risk calculation, and risk response. So the asset, without an asset, we don't have any risk. But what is risk? Risk is likelihood of something negative happening to assets. So risk is impact times likelihood. But how does this happen? This happens only when the threats are exploiting vulnerabilities. Okay. Therefore, actually, there are a few things we should have added to this. We should have added vulnerability management. And we should have looked at what? So that in that overall risk calculation, we have actually that probability, if they put it in here. So probability of something happening times the magnitude, the impact. Okay, that is how we determine the risk. So we have a few different ways to calculate this. We can do this quantitatively or qualitatively or semi-quantitative. Quantitative means we're using numbers. And qualitative is we're doing it relative. We're making a judgment call. Okay. Which one do you think we prefer, quantitative or qualitative, if we had a choice? If we have a choice, it is always going to be quantitative. Exactly right. Why quantitative? Because it's more objective. Okay. But do we always have the numbers? Do we always know what the likelihood of something happening? Do we even know the exact asset value? Not really. Okay. So, so we don't necessarily always have the chance to do quantitative, so we do qualitative. So can we determine what is more or less important? I think we can. Okay. And we should. But there is a compromise between these two. Compromise is what? Semi-quantitative. What does semi-quantitative mean? We take qualitative, and then we take that qualitative and turn it into a little bit of quantitative. So we take things and then we put a numbers around them. Okay. And this is still not great, but it's a little bit. We want more objectivity as much as possible. Okay. So when we are doing our audits, what do we need to do? We must do risk-based auditing. So we need to look at all those things. Does the organization have knowledge of business, of the industry, and look at the results, previous results, regulatory situations, looking at the controls. Are they effective? And then maybe even apply some compliance tests and substantive tests. Compliance test only looks at things that are part of the compliance requirements. Substantive looks at everything. Okay. Do we really have time to have more of this? Yes. Yeah, that is true. You are 100% correct, Joe. Yeah. I mean, just a simple example. How much are these slides worth? Could somebody tell me what's the dollar value for these slides? Yeah. We don't even know, isn't it? Yeah. How much is a company's reputation worth? So, And then when we're doing the audits, there is also test and there is the audit. So there's a compliance audit and then there is a substantive audit. Compliance audit means you're meeting the compliance requirements, which basically means what? You're meeting the minimum. Substantive means what? We're going through doing it at the more general, we're looking at everything. But can we really look at everything? No. So what do? We apply a lot of statistics. What are we doing? We make sure we have good samples. Good samples that will represent the population. Okay. And then we'll conclude our audit to create recommendation to show where we can improve. Okay. And write an audit report. Excuse me, I'm sorry. All right. So this is the risk stuff. Any questions on risk management and so on? And we don't really have enough time to go in details. This is really a 4-day class. You know, trying to put 4-day class in 2 hours is impossible. So you're just going to go to most of the important highlight stuff. But this risk management is not that much different than any other risk management. But there is one thing that I like about them also. They see compliance as another risk. And I like that a lot. Okay. So project management. Now, according to ISACA, project and programs are not the same thing. So program is what? So for example, you go to engineering school, what do? They say, what's your program of study? You say, hey, I'm studying electronics engineering. Then within your program, what do you have? You have a whole bunch of classes that you have to take. So program is that group of projects. They have to be time-based, okay? More complex, longer duration, higher budget. Like program might be like identity and access control. And then the projects within the identity and access control might be implementing multi-factor authentication. Okay. So projects are more specific objectives that are aligned with what? Aligned with the program, part of a program. Okay. Always time bound. You know, you start date and date, and you break them into explicit phases. Say, you know, phase 1, phase 2, phase 3, and so on. And of course, you know, even within the phases, what you might do is what? You know, make sure that we have, you know, point of action and milestones, and make sure that we are reaching those and we are progressing towards the goal. Okay. My company right now, we're working with another company to create some app for them, mobile app. And, you know, our initial phase was, you know, setting up the mock and, you know, the design and so on. Now we are in phase 2. Phase 2 is we are actually building the product. Okay, and phase 2 is going to be much longer. But first phase was only a month and a half. Second phase is 6 months. Yeah. And then the third phase is going to be completing it. So the whole project should be done in about a year or so. Okay. Okay, so project management. Now it's a good idea to have what? Specialized project managers managing this project. You know, or if whoever is working on it understand these project management concepts. Okay, we need to understand these dependencies and then make sure that we're able to move ahead, because sometimes a lot of people work very, very hard, but they get the wrong thing done. And what happens? Project is not able to move on because what? They didn't think about an important dependency. Because of this dependency, didn't happen. It, you know, it just everybody else ends up waiting. Okay. And I don't know if you ever worked on a project like that, but it's very, very frustrating. Yeah. Because people didn't think about it, and some of it is, there are some constraints that we need to understand are not even coming from us. Some of it is regulatory constraints. Are you going to make government work faster because you want them to? Not really. Okay. So, and so therefore, is the project management depends on the size of the organization, the complexity of the business, and the auditor must understand those different project management standards and so on. Uh, you know, so there is like a project management body of knowledge, PMBOK, IEEE has a standard, Office of Government Commerce in UK has a so on, and then of course, uh, there are other certifications that are about project management and so on, that that people understand these things. My background, I'm from an engineering background, so I had several classes in project management, and those were some of the best classes I ever took. I am so glad I learned those skills, and that helped me. Most projects don't get on done on time, but at least understanding these constraints and responsibilities and spreading these and getting the management's buy into things, all of these are important, because anything in our world, if management doesn't buy into something, what happens? Nothing. Nothing happens. So common objectives of the organization's projects needs to be aligned with that, risks and the resources. We must have the proper resources. I'm so sorry. I'm a little sick. I hope you know. I think I will survive, but hope it doesn't impact the class that much. And this resources, where does the resources come from? Thank you, Joe. It comes from the management. If the management doesn't give you resources, then it doesn't matter. But we need to realize we don't have unlimited resources. No organization has unlimited resources. Yeah. Thank you, Anna. Yesterday I slept at 7 p.m. and woke up at 6 a.m. So I was feeling miserable yesterday, but today I'm much better. Hopefully, after this class, I'm going to do the same thing. I go to bed early, and hopefully, sleeping is going to heal a lot of this. All right. I'm sure you heard of this SMART objectives. We want to be smart. What does SMART mean? We want it to be measurable. We want everything to be measurable. We want every objective goal to be attainable, but we want our goals to be realistic, and it needs to be timely. Okay. So in our world, this is what we want. We want it to be measurable, attainable, realistic, and timely. Okay. And what is auditor's role in this? Make sure that there was an oversight on the project. So we actually have, hopefully with major projects, so we have the mission, the strategy from the senior management. And then we have the middle management who's going to be doing a lot of this work. But what we want is some kind of a steering committee. And what does the steering committee do? make sure that we are going in the right direction. We are not steering away from it. So we are sticking to the mission, because one of the biggest problem in many organizations is what? Everybody likes to work in their own silos. And we don't want this. We want, everybody working towards the same goal and the same mission. And that steering committee helps with this. Make sure the risk management methods are there. We have an issue, problem management, cost management. Two things that is common to almost all projects is what? They don't get done on time, and they are almost never on budget. Okay. But hey, some of them do get done on time. I was so impressed. I don't know if you remember, but I-75 bridge had collapsed in Atlanta. I'm in Atlanta. I live in Georgia, and that bridge was supposed to be fixed in like 2 months or 3 months, and they got it done in like in about a month. Yeah. But they gave the construction company a lot of incentives. They say, hey, if you finish early, you get this much more money, and they did it. Yeah. So it is possible. They brought in all kinds of people day and night. They all worked and they got it done. And I was happy because this was the road that was going to Atlanta. It was crazy. It was terrible times. Uh, change control management. So change management is critical thing, because we need to control this change. We need to make sure that the risk associated with the change is also minimized. Okay. Stakeholder management. Stakeholders need to be part of these. And then at the end, sign off. Okay. But everything we do in the project, everything we do needs to have a business case associated with it. There has to be a business reason for it. Okay. And this business reason needs to tie back to the mission. So, whatever the project we are working on needs to have what? It needs to be tied directly back to the mission of the organization. So when we come up with project requirements, actually, we have a mission requirement. From the mission, we have our business requirements. From the business requirements, we have specific security functional requirements and non-functional requirements. So we need to tie back everything back to the organization's mission. Okay, but that's not enough. We also must have return on investment, or cost benefit analysis, or return on security investment. So meaning what? If I spend $100, I need to get more than $100 in return. And this is the big difference between management and an engineer. As an engineer, I want to solve problems. But management sometimes says what? You don't solve these problems because what? Solving this problem is going to cost us more than the problem itself. Okay. So, we need to make sure that whatever the control we put in, whatever the project we're going to work on, and so on, is going to always be what? We need to make sure that we're going to get our return on investment. Sometimes, or even many times, what happens when projects are created, the security requirements are sort of ignored. If you ignore the security requirements at the beginning and you start adding them later on, what happens? Cost of this project goes beyond what was planned, and it's going to cost a lot more. So maybe this project should have never started from the beginning. So we need to make sure that we put in the feasibility studies, should we even do this, we need to make sure we put in that security requirements. We need to make sure that security is baked into this process from very beginning. Yeah, exactly. And quality. All right. So again, business case provides information required for organization to decide if the project should proceed or not. It's you're looking at the cost versus the benefit, and we must have a business case. And I used to work for a poultry company, and we used to meet the board like once a quarter, and we would present them our projects, and some would get approved and some would not get approved. So initially, every one of my projects were denied. So I just looked around. I looked at the other projects that are accepted. I was telling them all technical stuff. I said we should do this and we should do that, and I realized that's not what they were looking at. I started telling them, hey, this project is going to save the company this much money, or this project is going to make the company this much money, or this project is going to reduce the workforce by this much. And all of a sudden, what do you think happened to all my projects? They all got accepted. Okay, so and that's when I learned this is how it needs to be, and now I realize how correct they were. It's all about they don't need to know the details of technical stuff. They just need to know what is this aligned with the business goals and missions? Is it going to add something to the business? Okay. All right. So we come to does anybody need to take a break, or should I just continue? Because this is a completely new topic that is related to the project, but SDLC lifecycle. Okay. All right. So software development lifecycle. Yeah. And I'm honestly very happy that I hear this. Today, I think our biggest weakness in our industry is this. So my company, I do training for training camp, but I have my own company and we do software development. Okay. And we do a few other things. And I used to be a developer myself. I moved to Georgia because of Y2K. So when I was writing code, do you think security was even, there was ever a thought in my mind? Did I ever think about security in my mind? No. Do you think even today in colleges, and I still teach at college, do you think they teach this in colleges today? I talk to faculty who teach development classes, and they don't necessarily talk about this, because part of it is because they don't know it themselves. Okay. Their books might have it, but today 80% of our attacks are coming from where? Applications. 80%. I know network security is extremely important, and I'm pretty good at networking. But this is an area look. It took me 2 years to get my own developers to put them in the right mindset that security is also their problem. So, we need to make sure from the beginning, very beginning, that we bake in security to our software development. I am actually not big fan of secure software development lifecycle. All software development lifecycles should be secure. Trying to add security to software after it's built is just like trying to fix your foundation of your house after you put the house on top of it. If any of you ever bought a house, how often do you go? When did any of you buy a house because it had good foundation? We don't. Okay. But you know, the security, and you are 100% correct. We want things done quickly, and you know, we want it to be done quickly and you know, most economically. So what adding security to it delays things. But we need to understand this. Fixing it afterward is going to cost us 10 times, 100 times more than fixing it before. Sometimes actually we need to completely break it to fix it. You know, like sometimes the doctors break a bone that was healed so that it can heal better. They re-break it, which is so, you know, difficult. You know, you have a bone that's healed, but it's in the healed wrong, so they break it again so it will heal right the next time. So we need to make sure we're baking in security from all the way from the beginning. So the first step is, should we even do this or not? Feasibility. And I just talked about this a few minutes ago. The biggest problem in the feasibility study is, since security is ignored, what happens? Sometimes organizations say, yeah, this is feasible, let's do this. But later on, when you add the security cost, it becomes too costly to even what? To implement it. Okay. So let's say we did the feasibility study and we think that this is a good project and we're going to get more out of it than we put in. The next phase, one of the most important phases, is coming up with the requirements. And this is where we come up with requirements for both functional requirements and non-functional requirements. Do we know the difference between functional and non-functional requirements? Functional requirements is what the application needs to do. Non-functional requirements is how it needs to be. So one is about what it does, the other one is the performance. But we need to make sure that we put in functional security requirements and we put in non-functional security requirements. So what might be a functional security requirement, like saying, hey, we need to make sure that there's a proper authentication. That's a functional security requirement. Or you need to say data address is encrypted with AES, you know, encryption. Okay. The non-functional security requirement might be it's about resilience. Yeah. Or it's about its recoverability. if it crashes, how is it going to be recovered, and what is it going to disclose? And in the requirements phase, we need to also come up with our use cases, and use cases are almost always tied to the functional requirements, but we also need to have misuse cases and abuse cases. What are misuse cases and abuse cases? Misuse cases is how a use case might be abused or how it might be misused from the attacker's point of view. For example, you might have an online shopping site. You know, use case is what? People put in things in their cart, and then they check out, they make the payment, and then the order is processed and it gets shipped to them. Misuse or abuse case might be what? They put everything in the shopping cart, everything the organization has, and they never check out. Because they never checked out, what happens? It looks like all the items are, none of the items are available, but in reality, what? None of them have been sold yet. Okay. So we need to think about all of this. Can we think about all possible misuse or abuse of a system? Well, it's difficult to do that, but we can still come up with the typical ones. Yeah. And the left-hand side of the slide is if we are buying it, and the right-hand side of the slide is if we are building it. Should we build it or should we buy it? Well, depends. If there is stuff out there that meets our requirements and it meets our both security requirement and functional requirements, then Yes, we should buy it off the shelf. But if it is not there, then we might have it built. So, you know, in both cases, what we need to do is we need to make sure we are still testing it properly. Okay. But in the design phase, we need to do threat modeling. What does threat modeling mean? Threat modeling is pretty tough. Threat modeling means we try to see what potential threats can be there. You know, we do data flow diagram, or we do you know, attack surface calculations, and we look at the possible threats that can be there. But you know, at the end, we have endless possibilities of threats. So what do? We look at, you know, typical threats, typical things, and there are tools that can help us with this. You know, there are databases and things like that that can help us with this. Okay. And so we do the design. After we do the design, we do the actual development. And then when we are doing the development, we really need to make sure that we're following the secure software development methodology. So I agree with you, testing is limited to requirements, but those requirements, if we do a good job at the requirements to include security requirements, then that would be even better, isn't it? So many times we don't put these security requirements as a requirement. And even the software development, you say, hey, these are the things that you need to make sure that you put it in your code, that you're following these things. And when we do the testing, we really should test to see that these requirements are met. They are following these guidelines from SANS and OWASP and the Software Institute and so on. So there are a lot of them out there, but you know, developers want to do whatever they want to do, and we want to say no. You need to use a standard system, and you need to follow these standard ways of doing things. Okay. On the left-hand side, if you're selecting it, you know, most of the time we select it based on what we need, not based on what the security requirements are. And at the end, if you do both, then you'll be okay. But what happens is usually when you find a product that does what you need to do, then that's the end of the story. But that's not what we want. Okay. We want to make sure that it meets these requirements, because there's so many software out there that we have no idea what they might do, because we don't even know where it is coming from. Yeah, exactly. Freeware, what could go wrong? Yeah. And I'm a big fan of open source, to be honest. But you know, how many of the open source stuff is actually created with security in mind? You know, they're just doing it because this is what they want to do. You know, right? So, and then the misconfiguration. Even this configuration stuff is kind of important for our development stuff. The misconfiguration is such a huge issue for us. We want to always use the concept of least privilege. We want to give our applications the minimum level of access. You know, we don't want to, so we just want whatever the process is running, whatever the application it is, whatever the system we're going to do, especially if you're buying things off the shelf, it's going to come with 15 features. Most probably the companies are buying it for one or two of the reasons. What happens to those other 13? They become a risk to an association, to organization. They become a major risk. Okay, so exactly, deactivate what you're not using, or completely get rid of it if you can. Okay. And then we do the testing to see what all our requirements are met. All, you know, So we do integration testing, and we do compliance testing, and we do user acceptance testing. We test to make sure all the requirements have been met. Okay. Once all the requirements are met, we are good. We feel good. Are we done? Of course not. We need to have certification and accreditation. What does certification mean? Certification means that it meets the requirements. Accreditation means what? The senior management's accepting of the product and putting it into production environment. Okay. So they put it into production environment, and are we done with this? Have you ever seen an application that gets put into production environment and remains as it is until the day it is you know, it being stopped used? No, I mean, I'm sure there is some out there somewhere, but not that I know of. So we're going to have this maintenance. We're going to find issues, we're going to find bugs, or they're going to ask for new things. So when this happens, where do we need to go? All the way back to phase 2 again. All the way back to the new requirements. There's no shortcuts. And this needs to go through change management. You go through the top, again, come up with new requirements, do the new design and new development, new testing. And actually, the new testing is going to be now a little bit tougher, because now we do regression testing. What is regression testing? Testing everything we have tested before, and now testing all the changes to make sure that we didn't introduce anything new. Okay. Any questions on these phases of software development lifecycle? So thank you. And if any of you are interested in this, and this is the certification you should look up. Okay. And training camp offers that class. Okay. All right, so software development methodology. I bet you almost all of you are using what? Agile. Am I correct? But the methodology we used to use was what? Waterfall. You know, waterfall is a good methodology. The problem with waterfall is it's very rigid. And agile is more agile. It's more flexible. But you know, some people misunderstand agile. Agile doesn't mean we are changing the requirements each time. Agile means what? We're more clearly defining the requirements. Agile means if there are issues, we deal with the issues before they become too big. Okay. No. Exactly. Better feedback from stakeholders early. Exactly. And we're working, and the beautiful thing about Agile is we are working with the stakeholders. We are working with the people who are going to be actually using this. It is not what I understand is they need. They tell me is exactly what they need. Okay? But the problem with the Agile is what? It's not necessarily the problem of the Agile, it's the problem of the implementation of Agile. The security gets ignored many times. Okay? Because it's about stories. Well, how often the stories are about misuse cases? Most of the time, the stories are about what? About use cases. Okay, we need to create these misuse cases. So there is actually something called secure agile. Any of you heard of that? Did you know that there's something called secure agile? It's kind of sad because all agile should have been what? Secure agile. All DevOps should have been secure DevOps. Okay. You know, so instead now we have DevSecOps. Okay. So, but yes, there is something called secure agile, and there is actually another one called Samba, which is also building in security into agile. Okay. And the rest of them are prototyping. Well, almost everything we do a prototype. Rapid application development is more like an agile also. Object-oriented system, almost everything we do today is object-oriented. Reverse engineering. Well, we do this a lot with malware and stuff like that to see what they did. Or companies do it also for what? To you know, to reverse engineer and someone else's products to, so they can create theirs and stuff. Component base is a great idea. We build it in components, then we can add them and later on bring it. And we want things that are highly decoupled. We don't want coupled system. We want modular systems, exactly. We want isolated, separated, independent systems. We have like microservices. We go even beyond this. So, and then a lot of the applications are going to be web app because of what? Because of cloud and because it makes it so much easier. But there's also software re-engineering. Like software engineering, engineer is somebody who designs. What is software re-engineering? Yeah. So this is involving, doing it better, a little bit better. Exactly right. Yeah. All right. So what is the auditor's role in this re-engineering and so on? Yeah. Looking at the effort, overall culture. Does the culture of our organization matter? Yes, it does quite a bit. You know, so re-engineering means, we always do incremental changes, but at one point we say, hey, there's not that much more we can improve. So we come to a point where we say, okay, we're just going to do it, redo it, break the thing, and then start from scratch. Okay. All right. So let's take a break now. I think this is a good point uh, to take a break, and we'll look at some physical architecture and implementation planning and so on. But I think this is a good. So let's take a 10-minute break. Would that be okay? All right. Do you mind if I put a timer on the screen? See you back in 10 minutes. All right. Well, thank you all. Let's see. Let's continue from where we had left off. So physical architecture analysis. Do we care about the physical security and physical architectural and even logical architectural? It is not just the application, it's the environment also and the physical stuff we're getting. So reviewing of the existing architecture we have, validating that proof of concept, analyzing the design, drafting the functional requirements. Remember, functional requirements, also the non-functional requirements. And then the final requirements and the proof of concept, and then delivery of the prototype. So we have in the implementation planning, we have the procurement phase. This is the phase where we create our requirements, request for proposals, coming up with the communications and the deliverables and the contracts. So who we pick is important. How do we decide that the company organization we're going to work with is a trustworthy company? What is the best way to do this? Is trusted third-party audits, trusted third-party certification, trusted third-party verification and validation. Okay. So once we know that we can trust this organization, then what do we need to do? We need to come up with a good, enforceable contract. And the most important part of the contract is going to be our SLAs. SLAs are service level agreements. The level of service that's going to be provided by the vendor. Okay. And then we come up with a delivery time. Well, do we say, here you go, you're going to deliver this in 2 years and let's see you back in 2 years? No. What do? Is we come up with the priorities, goals, and then make sure that they are working towards that delivery time. We don't say, okay, what happened in 2 years? No, we make sure that they are progressing towards this date and they are going to be able to actually return it, deliver it on time, and there must be consequences if they are not. If there are no consequences, this is the nature of human, human nature is like this. If there are no consequences, we don't care. Okay. In general, I'm sure there are some very conscious people, very good people who would do the right thing even if there are no consequences. But most of the humans don't do things unless there are consequences. And incentives, exactly. So there has to be that consequences. I would include incentives as a consequence. Positive consequence versus negative. But I agree. Carrot and a stick, and and then develop and review the plan of the installation, and then the test the installation. Okay. Test cases, requirement specification, making sure we have metrics, and so on. So I talked about this a little bit earlier. We want to have unit testing. Unit testing is done by the developers. So developers built each unit and they must test their units. But once these units are built, they are like blocks. They are like Lego blocks. We need to put them together. And we need to make sure they work together. This is the integration testing. That's why we call it actually continuous integration. Continuous integration is the build process in the DevSecOps. Okay, so building it, but making sure they're all working together. Once we know that they're all working together, then what do? We do the system testing. Okay, and then we think everything now is working great with the system. Final acceptance testing. Who does the acceptance testing? Mainly the end users. Okay, but there is also quality assurance testing, and then user acceptance testing. Most important test, of course, for the acceptance testing is the user acceptance testing, but it is not necessarily enough. We want to make sure that the quality assurance, quality is at a level that we're going to accept. Now, there is no such thing as a perfect software. So this software is going to have some issues. We just need to make sure that these issues are at an acceptable level. And then user acceptance testing, there might be some also like compliance acceptance testing and agreement acceptance testing, and then another integration testing with the system and so on. Okay. Then there is the alpha testing and beta testing. What is alpha testing? What is beta testing? Alpha testing, these are basically your last tests. Alpha testing is the testing done by the internal team, and the beta testing is the test done by a volunteer customer. A lot of my software, when I build it, we work with the customer. We say, hey, you need this. We will build it for you, and then we will treat you like a beta tester. And then once we have this, then we will, once we have it perfected out, then we will test it too. We will start selling it to others. Okay. And there are also white box testing and black box testing, and actually there's also gray box testing. What is white box testing? Well, we know everything about the system. And the black box testing is what? Where we don't know anything about it. But in most of the time, it is rarely that we know everything about it, even if it is completely built in-house. Because a lot of the stuff are going to come from somewhere else. The libraries and some of the other tools and so on are going to be somewhere else. So most of them are going to be gray testing. But if you're buying off-the-shelf software, well, it's going to be all black box. Do you think Microsoft is going to give you the source code for their software? So those are going to be black box testing. Okay. And we have talked about this quite a bit already. Functional testing, and also we should do non-functional testing. And do you remember what regression testing was? Anytime we make a change, we test that, but we also test the previous things we have tested. We make sure all the bugs that we thought are dead remain dead. Okay. And the problem with regression testing is what? Every time we do an iteration, regression test is growing. After the 100th iteration, what happens to regression tests? Much, much longer. After the 150, even longer. So what gets ignored? I just talked to a company a few days ago. They said, we do only regression testing of the last 3 changes. So they are doing regression testing, but they are not doing on everything they have fixed. They are only doing it on last 3 changes. At least they were honest and they accepted this. They told us this, which is not right. Which is not right, because many times when you do an update or fix something, what happens? It breaks something else, isn't it? Yeah, many times that's the case. Okay. Who has heard of sociability test? It is important, sociability test, both acceptable to end users and both to the existing systems. If it doesn't work well with the existing systems, or if the users are not going to accept this, what are they going to do? They're going to find ways to circumvent it. And so we don't want the environment, we don't want it to negatively, adversely impact the system. And parallel testing is what? You have 2 tests. Yeah, that is a little bit outside, but it is important that we understand the culture and we understand the system. So it's system integration and then also the culture. Okay. But when we're going from one system to another, parallel testing is great. What are you doing? You're using one system while you're testing the other, or you're saying, I'm going to move to this. But the problem with the parallel testing, and I faced this recently, when I say recently, last year, we build a PACS system. Anybody knows what PACS is? It is a server that holds images, medical images like X-rays and MRs and things like that. So this customer's PACS system was using Internet Explorer. And Internet Explorer was what? End of life is coming. So we told them end of life is coming. You need to come up with another. So we got him something. And we told him, I said, here you go. Here's your new PACS system. We're sending images to both of them. But make sure you test it to see, let us know before the other one goes completely down. Let us know what's going on. And what do you think happened? For a long time, we didn't hear anything. We thought our system is working perfect. One day we got a call saying, hey, nothing is working. All this is all down and so on. And then we check out the system and there were really issues. And we checked the old system was completely down because Microsoft decided to really end the Internet Explorer. But in this meantime, where they were doing the parallel testing is everybody continued using the old system. Nobody used the new system because they didn't use the new system. None of these issues became aware until they had to use it. Okay, so we need to make sure if you're using a parallel approach, which is a good approach, we need to make sure that it is really parallel. They are really using it, and we had this problem. So anyway, software testing. It's really we have been talking about software testing, but I wanted you to see this also. We have a bottom-up approach versus top-down approach. And which approach should we take? The answer is yes, we should take both approaches. We need to begin testing from the individual units and work upwards, but also look at it from the complete system and work downwards to units. So we have these dependencies, or we look at it, is it upstream or downstream? Are the examples meeting the requirements or the requirements meeting the thing? So we need to look at both ways. We need to be open to both of these things. Okay. So this is not that critical, but I thought you should see this as a potential approach for testing it. Right. So here is an important thing. Quality assurance and quality control are many times treated as if it's the same thing. And unfortunately, I'm really sad about this. In the software environment, we call our test teams quality assurance teams. But in reality, quality assurance comes from where? It comes from independent third party. Okay. We must have true independence if we want assurance. Well, if somebody is working for us, are they really truly independent? No, they are not. If we are paying for their salaries, then we are not. Actually, full disclosure, my sons work for the big four, Ernst & Young and Deloitte and so on. And even them, I tell them, I said, look, your companies are hiring you, but they're paying you. If they don't like your results of what you tell them, what's going to happen next year? They might find someone else to do it. Okay. Quality control is more what? Internal. Which one should we do? The answer is obvious. We need to do both. But but what we would prefer, what is more important to us, is that quality assurance. This gives us that level of independence, that level of assurance that it meets our requirements, or it will bring the risk level to an acceptable level. But quality control is internal. We must do that also. But in all the other industries in the world, what do you do? It says this shirt was inspected by this person. That's a quality control inspection. But would you trust an organization that says we are doing great, we have no problems, we are the best in the world? Would you believe them? They all say that. By definition, there's only one best. How come they are all best? So how do we get this assurance? We get it from independent third-party verification. But we would like it to be verified and validated. What does verification and validation mean? Verification means they are doing the right process. It's being built right. Validation means the final product is the right product. So we verify, and then validate. And we want that independent verification and validation. IV and V, this is not Roman numeral 4 and 5. It's independent verification and independent validation. Can we have quality management? Of course. Quality management means what? Continuously improving the quality. What makes one organization more mature than another? It's their processes. Do they have well-defined processes, and are they improving on their processes? And in our world, there is always room for improvement, always. Since there is no perfection, that means we can always make it better. We can always improve on our software. We can always improve our operations. We can always improve on how we buy things and how we sell things, our security, HR, whatever we are doing in our organization, we can always do it better. When the organizations start failing, when they say, we are doing great, we are the best, we don't need to do anything anymore. That is the beginning of the end. When organizations say we're good enough, we don't need to anything, that's the beginning of the end. I don't want to give names of companies because this is being recorded, but there are so many examples of this out there. Okay. So we must do a good job also of change management. Change management is so critical to our organization. Change management is about minimizing the risk of change. Is change going to happen? What do they say? The only constant in life is what? The change itself. It's going to happen. But what do we need to do is we need to make sure we control this process. We make sure that we go from one good state to another good state. The hardware is going to change, software is going to be changed, network is going to be changed. There'll be new processes, new devices in place. So we need to control this. But the change management process, the most important aspect of the change management process is actually accepting of the risk. And who needs to accept the risk? Senior management. So somebody from senior management needs to be where? Part of the change management team, so they can actually make this decision. Okay, so we need to make sure that all the stakeholders are part of it. We are always documenting things. We're going to talk about, really, there are, according to ITIL, there are really 3 different types of change, but some of the changes are pre-approved. So that's kind of silly, isn't it? You're approving a change before it even happens. Why would you approve a change before it even happens? Because the risk is low and because we want to make sure that it is documented. Okay. So, we make sure the risk associated with this change is planned, and we have option to go back, and and we make sure all the stakeholders are part of it. But most importantly, there has to be somebody from senior management who can make this decision and who is really accepting that risk, who has the authority to do this. Okay. So does change management slow down progress? Yes, it does. Okay, it does. But is it absolutely necessary? Do you need to see your dentist every 6 months or so? If you don't, what happens? A simple cavity turns into root canal, and root canal turns into implant, isn't it? If you see him every 6 months, what happens? It's okay, here you go, we cleaned it. But it's not about being cleaned. It's about what? Checking it so that we can deal with issues before they become too huge. Okay. Change management is like this. We want to make sure that we don't have any unintended consequences. We make sure that we go again from one good state to another. Yeah. There's a change request. There is the authorization. Usually, before authorization, what happens? They do a risk analysis to see if this is something should be done or not. And sometimes, I was a member of change boards. People would come say, "I need this software," and we'll tell them, "Hey, you know what? We have this other software that does what you want and more, and we don't need to approve any change management because it's already in the approved list." Everybody's happy, isn't it? Because we didn't have to accept any change and they got what they wanted. But we don't always get that lucky. So we do the risk analysis and then we authorize it. Unfortunately, what happens to some of the change management groups, when the authorization happens, they are done. They don't follow up. They don't go through it. But we need to make sure that it's tested properly, it's implemented properly, and it is documented properly. Okay. All of these are properly, documented. We go through this process. We follow it all the way to the end. This is part of the change management. And the types of change that I was talking about are these three types of change. Emergency change are what? Changes that are needed to be done right away. Because of what? Maybe because we are under attack. So we don't have time to wait for the next board meeting, change board meeting. We just go on and call somebody and they approve it. And then major change, this is called actually also normal change, is when there is a change like a new software or new hardware or a major change to the software or something, you go through these steps that we just talked about. Okay. And then the minor changes are called the standard changes. These are the low risk changes. And these low risk changes are the changes that are pre-approved. Pre-approved. Okay. Yes, minor change would be a patch, absolutely. Like Microsoft Windows updates and so on would be considered a minor change. So we don't sit through and have a meeting each time to say, hey, should we do these Windows updates? They are already approved ahead of time. Okay. But they still need to be tested. We still need to make sure that it applies to our environment and so on. Absolutely correct. Okay. All right, so that's all I had for this. I think we covered everything that was in there. So this is my name. This is my personal telephone number. This is my personal email. So I'm giving you these in case you have questions about this class or any other class. I'm sure you can contact Training Camp directly, but I'm here also. I know quite a bit about a lot of the classes. I don't do all the classes, but I have done a lot of the classes. So, and if about any class you have, yes, you should get 2 hours of this for this class. And if training camp, if you need verification or something, if I'm sure somebody from training camp validate this. If not, contact me. I can send an email saying that, hey, you were here for this period. Okay. So, and thank you so much. And Now I'm open to any other questions you have about this or anything else. And I'm happy that you took your time up, right after work coming to this. Appreciate it. I hope this was a useful use of your time. Thank you, thank you. I appreciate you. Wishing best wishes. Thank you. And I hope to see you in classes. All right. So yeah, and I'm serious about those. So you can contact me anytime with anything. Okay. All right. Okay. So if you have questions, I will hang around. Otherwise, hope to see you somewhere else. Thank you. Appreciate it. Thanks. See you, Joe.